#hashtag walkthrough, day 27, Ignite. #hashtag objective. Compromise the target machine by exploiting a vulnerable Fuel CMS installation, obtain an initial shell, perform post-exploitation enumeration, escalate privileges to root, and capture both flags. #hashtag step 1 in machine deployment. Started the TryHackMe Ignite target and confirmed it was reachable from the attacking Kali Linux machine. Connectivity was verified using ICMP before beginning reconnaissance. #hashtag step 2 network enumeration. A full TCP port scan was performed against the target. The scan identified an HTTP service running on port 80. With only a web service exposed, the assessment focused on web application enumeration. #hashtag step 3 website enumeration. Browsing the application revealed a Fuel CMS installation. Further inspection identified the CMS version as // Fuel CMS 1.4.1 //. Knowing the exact version allowed public vulnerability research. #hashtag step 4 vulnerability research. Searchsploit was used to locate publicly available exploits for Fuel CMS. A remote code execution exploit targeting Fuel CMS 1.4.1 CVE 2018-16763 was identified. The exploit was reviewed before execution to understand how commands were injected into the vulnerable application. #hashtag step 5 exploit preparation. The exploit source code was updated with the target IP address. Once configured, arbitrary operating system commands could be executed through the vulnerable endpoint. Initial commands such as /whoami, /id, /hostname, /pwd. Confirmed successful command execution. #hashtag step 6 reverse shell preparation. A netcat listener was started on the attacking machine. A lightweight bash reverse shell script, ignite.sh, was created and hosted using Python's built-in HTTP server. This allowed the target to retrieve the payload directly from the attacker. #hashtag step 7 obtaining a reverse shell. Using the existing remote code execution primitive, the target downloaded the hosted script into /tmp. After making the script executable, it was launched from the target. The reverse shell successfully connected back to the netcat listener, providing an interactive shell as the www data user. #hashtag step 8 shell stabilization. The initial shell lacked proper terminal functionality. The shell was upgraded into a fully interactive TTY by spawning a pseudo-terminal and configuring terminal settings. After stabilization, standard Linux utilities became easier to use for enumeration and privilege escalation. #hashtag step 9 local enumeration. Post-exploitation enumeration focused on identifying /operating system information, /user accounts, /available privileges, /SUID binaries, /configuration files, /sensitive credentials. The operating system was identified as Ubuntu 16.04.6 LTS. Enumeration also confirmed that the current user had no useful pseudo privileges. #hashtag step 10 user flag. The /home directory contained a www data user home directory. Inside this directory, flag.txt was discovered. Reading the file successfully captured the user flag. #hashtag step 11 configuration file review. Application configuration files under the Fuel CMS installation were inspected. The database configuration file contained plaintext credentials. /username, root. /password, Nmap. This represented a credential management weakness. #hashtag step 12 privilege escalation. The recovered credentials were tested using the password authenticated successfully. This immediately granted a root shell without requiring any exploit or kernel vulnerability. #hashtag step 13 root verification. Administrative access was confirmed by checking /whoami, /ID, /hostname, /current working directory. The session confirmed full root privileges. ## step 14 root flag. The root user's home directory contained root.txt. Reading the file completed the objective and confirmed full compromise of the target. / #attack summary. / key. Findings. Fuel CMS 1.4.1 was vulnerable to remote code execution, CVE-2018-16763. /arbitrary command execution allowed initial access. / a bash reverse shell provided interactive access. / Fuel CMS stored database credentials in plaintext. / the root account reused the database password. / Credential Reuse resulted in immediate privilege escalation. # outcome. / white heavy checkmark initial access. / white heavy checkmark remote code execution. / white heavy checkmark reverse shell. / white heavy checkmark interactive shell. / white heavy checkmark user flag captured. / white heavy checkmark privilege escalation. / white heavy checkmark root shell obtained. / white heavy checkmark root flag captured.